I would like to introduce to you Lukas Greiner. Lukas has been working as a project engineer at Aquasys since 2016. He is responsible for the design and cost calculations of high-pressure water mist systems during the tendering stage. Lukas has diplomas in mechanical engineering and business management and more than 7 years of experience in different industry fields. He has also obtained several company-based training certificates in high-pressure water mist technology. And he's going to speak about concepts for healthcare services and facilities. Lukas, the stage is yours.
Thank you very much, Bettina. I'm very happy that it's already the second time that I'm allowed to speak here at IWMA. In this presentation, we will see a rough overview about healthcare services. We will see typical applications. We will see challenges in these applications, and we will see why water mist is so essential to use there. We will go into some special requirements from the customer side, but also from the environmental side. We will see some characteristics for the components of the system, but also of the system design itself. And afterwards, we will see some real executed projects which will round up this presentation. And also we will have a short conclusion at the end. I want to point out that laboratories and clinical service areas are somehow similar in some areas, because they are both high sensitive applications. They have both high sensitive equipment. And then we will take a look as well on patients and visitor areas, and on technical or storage rooms, which fulfills this picture. Let's see what are the differences at the complexity of the fire risks between those applications. So when we think about the typical hospital, the critical fire load is a little bit different, for example, compared to a laboratory. We have here the furnishings and the material for medical purpose, giving off quantities of heat. In the laboratories, we have complex material handling processes, and we can see the smoke. The risk of smoke is for all applications critical, because rapid spread of smoke and flue gas is a high risk for property damage or danger to human. And between those applications, also the time of escape is a little bit different in laboratories. The challenge is to get out of the laboratory. Sometimes they are split by doors, and so this is slowing down the time of escape. In hospitals, we have to take care about all the humans inside who are unable to rescue themselves. So also in night shifts, sometimes we have limited capacity, and this should summarize the complexity of fire risk. And we know that in our modern healthcare services and facilities, we have all these applications together: laboratories, operating rooms, technical rooms, storage areas. So yeah, this is a short overview about the complexity of fire risk. And we will see here that water mist, beside of the benefits which gives us the technology, because it is so flexible and adaptable, there is the technological benefit, like immediate effect, which is very critical and very important, and the immediate return to operation after an activation. It is reducing the contamination by smoke, and it's avoiding huge amount of contaminated extinguishing water, because we have less water. and we need small size of attention areas, especially for laboratories. It's very important. Let's see very briefly or roughly on the main rules and regulations. So the backbone is built by the national building codes itself, because they tell us where do we need a water mist system, in which areas, in which buildings, and how big are the fire sections, how should the system build up. We have to follow the common standards for high pressure water mist systems. In Europe, that would be regulated by the EN 4972, for example, or by the regulations of VDS and the standards of VDS. Then we have also additional design rules and recommendations, which are based on the one hand on the customer requirements, on the other hand on the environmental requirements. And I want to show one example for the laboratory industry. Here in Germany, the circle of experts called ELATEC has pointed out a statement, has published a statement already years ago, which was always updated since the years. And this gives us the minimum requirements for suppression systems, water mist suppression systems in laboratories. So this is very important in industries when there are statements of experts to consider them. Impact of biosafety precautions in laboratory is an important topic, and that's why it's dedicated to a separate slide. So the extinguishing medium must be threatened, definitely, to avoid any infection and any contact to the outside area. Beside of the constructional measures, which are, for example, special filtering concepts and cooking or boiling of the extinguishing agent to avoid the infections to outside, it has also direct impact on the system itself, on the piping system. So, for example, the piping to the sections can be separated by the use of section valves, and additionally we use check valves, which is preventing that the water from the laboratory areas, once it enters the areas, can run back into the system. That is very important, because the medium, once it enters the laboratory, it is important that it doesn't get any contact anymore with the outside environment. And water mist systems have this one huge advantage, that it has immediate response to the heat and the fire. It suppresses the fire, it reduces the heat, and that is also that saves also, or this prevents also that the filter concept itself could get damaged, which is very critical in laboratory areas. Installation in existing premises is a big point, because customers think already into the future what happens if a system has to be adapted or extended, and therefore we need easy recommissioning in the future. Advantage with water mist is we have very short times, therefore, and the small costs for any refilling are advantages with the water mist as well. We have the pipes, we will see that later, they are small and can easily integrate it into the building. That is positively impacting also the for retrofitting of systems. Let's see the component characteristics. We know that the systems use mainly stainless steel components. These are very high quality materials which we use here, and starting from the pump unit, which is compact and modular, it can be easily adapted. Going further with the piping and the valves, they are easy to fit in into the system design itself. Also because they are small, have reduced piping sizes between 12 and 42 millimeter. And the pressure range of the systems at the nozzle is around 50 to 80 bar for high pressure water mist systems. We use nozzles, pennant nozzle, upright nozzle, and also sidewall type of nozzles. We will see later an example where we have used them. So the whole system and all components are designed for pressure level of minimum 160 bar. This gives us the advantage to deal better with the pressure loss in the system, especially when it comes to long main pipes. When, for example, complex buildings are interconnected to each other, then it gives us benefits because the high pressure water mist systems allow more space for the, or more room for the considering the pressure loss itself. Let's see some system types for laboratory areas. We mainly use the open system, which is divided by section valves plus check valves to prevent that the water is running back into the system. We use the detection for very fast detection, and it's also recommended to have a dual detection dependency. Then we have in patient and visitor areas or in storage rooms or technical rooms, mostly wet systems. For sure, storage rooms and technical rooms, sometimes they can also be protected with open systems, but the main system which we used in our projects was the wet system, divided by alarm valves or flow switch. And then clinical service areas where also belong applications like operating rooms or special patient treatment rooms. They are mostly protected, that's from our experience, with pre-action systems and open systems. And we will see now one typical type. It's the A type for pre-action. Basically, there are two types, type A and type B. Let's watch this scheme from the detection until to the suppression. So first, once there is a fire, the detection will recognize this and give a signal to the fire alarm system. This will cause interaction with the alarm valve, opening these valves, and the pressure in the system, the standby pressure, will go down. This will be recognized by the pressure switches, which will give a signal to the control panel to start the main pumps. The water will be pressurized until to the nozzle, which we can see at the left bottom, and nothing will happen now until the glass bulb breaks, and only now water mist will be produced. The pressure switch will now recognize that the system pressure has been reached, and flow switch will recognize in which area from a mechanical side, in which area the system has been activated. So the main difference between the type A and the type B is that the glass bulb at the type B will cause already an activation of the pump and will produce and water mist will be produced. In the type A, we need dual dependency by the glass bulb and the detection. And for sure, there is the option to use water mist guns as well in the system. And we will later hear more. Water mist systems are flexible and easy to adapt because of these high quality materials which we use, but also because of the smart spray technology due to the higher pressure. We can ideally adapt them to space and surrounding conditions. They are flexible when it comes to the hydraulic concept and to the water supply concept, and the higher quality will also positively impact the lifetime of the system, and this has direct impact on the pipe installation itself. Let's see some examples for special solutions. Let's think about the activation valve, special valve solutions, which can be placed in the main line and activate open nozzles, electrical or hydraulic after electrical or hydraulic triggering signal. This is used especially when the nozzle is placed inside the room, not on the highest part of the ceiling, where the temperature would immediately activate it. Then we need these activation valves as a pilot valve. And the use of water mist wall hydrants are example for special adapted systems. We can either use it as a single system, or we can implement it into the fixed install system. The water mist wall hydrants are equipped with water mist guns, which can be used very individually based on the application of the scenario. Special tank forms allow us to use it in almost any form of pump room, and prefabricated pipe systems allow us to reduce the time on site, and also supports the site team. Now we will go into some projects. This is the state laboratory in Berlin-Brandenburg, which is where we protected Sarkozy's open nozzles, S3 laboratories with open nozzles. That's an example for laboratories with a very compact pump unit, only 112 liter per minute. This comes also due to the fact that laboratories should be protected individually by one section valve. Then we see that this is a very small tank which we could use, and it's directly connected to the automatic water refilling line. In Zurich, hospital was protected by water mist, the clinical service areas, and also the laboratory areas. And we used a very compact pump unit here with only 224 liter per minute, and connected to the automatic refilling concept as well. In this case, with pre-manufacturing the pipes in our factory, we could reduce the installation time on site, and this also extends the quality of the system itself, because less cutting, less dust at the site. Here's an example for a nursing home. It's near Oslo. The customer, the main benefit was that with water mist, a less amount of water was required. So an elimination of the need for extensive upgrade work on the public water pipeline was the huge benefit. We also could use sidewall nozzles for the patient rooms, for the elderly rooms, and therefore save. This sidewall nozzle spray can even spray around the corner, and this saved us additional nozzles in the rooms. Let me conclude this presentation. High sensitive areas require flexible and efficient firefighting systems. Water mist increases safety for patients, healthcare workers, and employers, and water mist contributes to the ongoing maintenance of healthcare services and facilities. Let's think a little bit further also beside of these huge healthcare facilities, in the future we will need innovative and efficient firefighting systems also for smaller practices, for smaller private healthcare facilities, and therefore water mist provides excellent conditions for compact and small systems. Thank you very much for listening to this presentation, and I hope I will be allowed in the future to present again. Thank you very much.